Now we want to find the angles theta, theta 1, and theta 2 when t equals pi over 4. Theta being the angle of the arc vector, theta 1 being the angle of the v vector with the r vector, and theta 2 being the vector of the angle between the v vector and the a vector. Okay, so the picture of that is here. It's not a very good picture, not very well drawn. But you see I've got v in purple, I've got a in blue, and I've got my r vector in yellow. So my r vector is about here when theta is pi over 4. That won't be exactly at the 45-degree angle because of the nature of the ellipse, but yeah, it'll be somewhere around there. The v vector will be here, and it makes an angle theta 1 with the direction of the r vector. Now I've extended the r vector out along this line so we can see an angle theta 1. And we'll have an angle theta 2 between the v vector and the acceleration vector. Okay, now the picture might or might not be accurate. The acceleration vector almost looks perpendicular to the velocity vector, and it isn't. And this angle I don't think looks like what it really turns out to be, so disregard this as a schematic picture. Let's see what it really looks like when t equals pi over 4. Well, maybe I better get this back up here. When t equals pi over 4, the sine of t is the sine of pi over 4. The cosine of t is a cosine of pi over 4. I wrote pi over 2 there. Because I was already in the mode to write square root of 2 over 2, most likely. Yeah, maybe just because I wasn't very smart this morning. I sure wasn't. Okay, sine of pi over 4 equals cosine of pi over 4 equals square root of 2 over 2. And in these expressions for the cosine of theta 1 and the cosine of theta 2, all you have is sines and cosines. They're all, each one of these is a square root of 2 over 2. The square of square root of 2 over 2 is 1/2. The fourth power square root of 2 over 2 is 1/4. And then if, unlike me, you're able to keep track of whether you're writing 1/4 or 1/2 or whatever, you can easily enough get these expressions. It's not difficult at all. You just got to write it down carefully and look for patterns. My problem this morning was I was looking for patterns and forgetting everything else I was doing, and it didn't work out. I made several mistakes. Okay, so t equals theta equals pi over 4, so the cosine of theta 1, make sure we don't lose this board here, cosine of theta 1, we're just plugging those numbers in. Yeah, and I'm not going to read them to you, I'm not going to go over them. Works out like this, okay? And the cosine of theta 2, well, it's identical to this one except for the negative here. So cosine of theta 2 is going to be negative 5 over 13. Now I should be able to estimate the I'm reminding myself of what I was doing here. Okay, here's our picture. Here's our v vector. Here's our a vector. Here's our r vector. Between the r vector and the v vector, the angle is the inverse cosine of 5/13. Since the cosine of theta 1 being this angle, is 5/13. And the inverse cosine of 5/13, I estimated that to be 65 degrees. People love to check me with a calculator. It turned out to be about 67. There's nothing impressive about that estimate. It's fairly easy to make. So even, people think I'm a genius for making those. Yeah, I just do a little numerical math. It's not deep mathematics at all. And I'm getting worse at it because I have less and less working memory. So it kind of gets in my way. But that's an easy estimate, so I was fairly confident I was close on that one. And over here you get a negative 65 degrees, meaning the vector goes from here to here, or the angle goes from here to here. That's still a 65-degree angle between the vectors. Except maybe that means the vector goes down this way. So that the negative 65 degrees. So you can think about that. and think about just what would happen if you plotted these vectors. I'm not going to get real explicit on that. And also to sketch the V vector, I sketched it here before I did this, but I didn't sketch the rest. I sketched another V vector over here. Showing that the angle of that V vector with the positive x-axis, something you could calculate by doing the arctangent of the y component divided by the x component. Okay, the y component is 3 sine t, the x component is 2 cosine t, and sorry, that's the r vector. Okay, so the direction of the r vector would be the arctangent of this over this. Since t is, for this picture, is pi over 4, the sine and the cosine are equal, so the angle here would just be the arctangent of 3/2. That would be the angle of your r vector. The angle of your r prime vector would be the arctangent of 3 cosine t over negative 2 sine t. Cosine t and sine t are again equal when t equals pi over 4, so that this is just going to be the arctangent of negative 3/2. I estimated that to be 110 degrees, thought I was probably within 10 degrees, but as I say, I wasn't in great shape this morning and didn't go into a lot of depth in making that estimate. I kind of made an intuitive estimate. Turns out it's 120 degrees, so I'd have been better off calling it 123 degrees to the nearest degree, at least according to somebody with a calculator in his hand. So that fits. So those are the angles we have. Now we just do this mainly just to get familiar with the V vector and the A vector and the R vector. What does this tell us about the motion? Well, we'll talk about that in the next video.